Build a model-type question, assess your ability to apply machine learning theory to real business problems. Interviewers are testing you on asking the right questions to understand the core problem, approaching the problem systematically, demonstrating depth and breadth of technical skills, evaluating solutions critically for practicality and business impact. It isn't about confronting real-world problems like build a restaurant recommender for Facebook, and then jumping to ML technique like logistic regression or random forest. Instead, it is about asking the right questions about business goals and constraints that inform the machine learning system design. It is about selecting the right model evaluation metrics and modeling techniques, contextualizing model performance in terms of business impact, discussing model deployment strategies, and much more. You can easily answer these questions by following these 9 steps. Step 1. Ask clarifying questions on problems and constraints. The first step is to frame the business and product problem correctly. It is easy to throw random ML techniques at data, but it is harder to understand the business motivations, technical requirements, and stakeholder concerns that ultimately decide the success of a machine learning solution. Interviewers expect you to ask the right questions, ones that scope down your solution. By clarifying these constraints and objectives up front, you make better decisions on downstream steps. Some questions that you may use to clarify the problem and constraints include: clarify definitions of some of the terms used in the problem statement. For example, if we are building a user churn model, it would be wise to agree upon a definition of user churn. How has the problem been approached in the past by the business? Is there a baseline performance we can compare against? What business impact is expected? If an incorrect prediction is made, how will it impact the business? Is an ML model actually a requirement, or would a simple heuristic or rule-based approach work well enough from a business perspective? You can then move on to clarifying some of the technical requirements. What is the required latency? For example, search autocomplete is useless if it takes predictions too long to load. Does every part of the system need to be real-time? While inference needs to be fast, can training be slow? Are there throughput requirements? How many predictions are needed to be served every minute? Where is this model going to be deployed? Does it need to fit on a device? Don't go overboard with questions. It is a time-bound interview, make sure your questions and assumptions are reasonable and relevant. Step 2. Establish metrics. Next step is to determine the best metrics for modeling. Always present at least 2 metrics to demonstrate thoughtful consideration of model goals and trade-offs. Metrics can be offline for model development and evaluation with historical data. Example: area under curve, F1 score, R-square, mean squared error, and intersection over union. Online metrics gauge real-time performance in a production setting, specific to the use case. Example: click-through rate, user engagement duration. Sometimes the business goal could be to optimize existing business KPIs. Example: time to resolve a customer request. In this case, align your model performance metric with solving the business problem. For a customer support request classification model, a 90% model accuracy means that 50% of customer tickets that previously needed to be rerouted now end up in the right place, resulting in a 10% decrease in time to resolution. Include non-functional metrics as well to demonstrate a comprehensive approach to measuring model benefits during interviews. Once you have picked a metric, you need to establish what success looks like. Is there a realistic threshold? Are there any baseline performance metrics? Note that in real-world scenarios, the bar for model performance is not as high as you might think to still have a positive business impact. Be sure to voice all the metric considerations to your interviewer so that you can show you've thought critically about the problem. Step 3. Understand your data sources. Clearly articulate what data sources you would prefer to use to address the interview problem. Think outside the box regarding which data to employ. Consider the following data sources. Can you ask users for data as part of their onboarding process? Can you purchase second and third-party datasets? Can you ethically scrape data from online sources? Can you send your unlabeled data to a labeling and annotation service? Also, think about artificial data synthesis and data augmentation. For example, if your traffic light detector struggles with low contrast situations, you could generate more versions of your datasets with lower contrasts. Take a few seconds to discuss nature of data source. How fresh is the data? How often will the data be updated? How was the data collected? Was there any sampling, selection, or response bias? Step 4. Explore your data. You should briefly mention the data exploration steps that you would go through. You can mention that you will begin by initially profiling the columns. Try to identify columns with no variance and hence limited predictive value. Noisy columns. A significant number of missing or unusual values. Look for summary statistics. Visualize the data. And also, visualize relationships using a correlation matrix. Step 5. Data cleanup. Handle missing values or outliers. Usually, we can drop outliers, and if there is a lot of data, then we can drop missing values. If data is limited, then we can impute data via average or any other method for dealing with missing values. Talk about outliers. How the outliers will be dealt with depends on the problem at hand. Talk about these with your interviewer. Remember, it is supposed to be a discussion. Step 6. Feature engineering. You will spend a good fraction of your time on these and the next steps. First, identify the target variable and how you would collect and label it, if necessary. Next, discuss the feature preprocessing steps you would employ. These steps depend on the data, but a few that can be used include transformations, binning, and dimensionality reduction. Talk about standardizing the data using methods like normalization, min-max scaling, and z-scaling. For categorical data, you may use one-hot encoding or hashing. If it involves NLP, consider stemming, lemmatization, filtering, bag of words, n-grams, and word embeddings. Balance positive and negative training examples. If you notice a significant imbalance, discuss ways to address it, such as upsampling, undersampling, and techniques like SMOT. Discuss possible feature selection. If you are using a deep neural network, feature selection may not be necessary. If needed, tree-based estimators can be used to compute feature importance. Additionally, you can use the L1 norm for regularization to force some feature coefficients to be 0. Optionally, you should mention biases or any other privacy or legal considerations. Once you have completed the above discussion, you should ask the interviewer if they would like you to explain how to operationalize these data steps. It shows strong engineering side. Step 7. Model selection and training. In this step you will propose few models. Some factors to consider while choosing are training and prediction speed requirements, budget, volume and dimensionality of data available, categorical versus numerical features, explainability. You should first give a baseline model, if possible. Typically you would have a baseline model that does not require machine learning. For example, a good baseline for a recommender system would be to recommend the most popular products to the users. This model will always be easy to implement, and you now have a baseline that all your other models should outperform. Then, speak about traditional ML models that are quick to train. For example, logistic regression or decision trees. Once you discuss those, you can then talk about more advanced approaches like deep learning. For each approach, you can start with a short explanation of the model, the hyperparameters, and the loss function. Then share the pros and cons of the model in context of the business problem and constraints. Now that you have picked a type of model or at least narrowed it down to a few candidates, interviewers will expect you to talk about how to train the model. This is a good time to talk about train validation test split, cross-validation, and hyperparameter tuning. Again, you should ask the interviewer if they would like you to explain how to productionize this component. Step 8. Deployment. Briefly talk about deployment strategy that you will use. It could be online, batch, or hybrid. Use the constraints that you already collected before to guide the decision. Some points to mention. Where to run inference. If we run the model on the user's phone, then it would use their memory, but latency would be quick. On the other hand, if we store the model on our own service, we increase latency and privacy concerns, but removes the burden of taking up memory and battery on the user's device. Monitoring performance. Some measurements that we should log would be error rates, time to return queries, and metric scores. Biases and misuses of your model. Does it propagate any gender and racial biases from the data? You should mention how often you would retrain the model. Some models need to be retrained every day, some every week, and others monthly or yearly. Always discuss the pros and cons of the retraining regime you choose. Bring up model degradation. Models change because underlying distribution of data change over time. Performance gets hit between the model in training and evaluation versus when model is served in production. Again, you should ask the interviewer if they would like you to explain how to productionize this. Step 9. Iterate. Always end with brief mention that the model will iterate to refine its prediction. You can do that by analyzing the wrong predictions manually, which in turn informs what project to work on next to improve the model. If you have time, quickly summarize the steps you have taken to build the model. If you are preparing for a data science interview or plan to start preparing, Make sure you download our free data science interview preparation checklist. It is an exhaustive checklist with questions and question types you know will be asked for sure in most FANG interviews. You can download it from link in the description. In the next video you see here, we use the 9-step framework we discussed for an Amazon mock interview with Jesse, how to build a product recommendation model for Amazon Black Friday sale.